Hey guys, welcome back to our today's lecture. In the last lecture we had discussed about the flow control and the data link layer, and today we are going to discuss the error control again in the data link layer. Okay, so as I have listed down here, it can be error control can be of two types, where one type is the complete packet. Okay, if there is this complete packet, the whole packet gets lost. Okay, so this is not much of a problem for us, because if one packet is lost completely, then we don't send the acknowledgement, right? You remember sender and the receiver. Okay, if the sender sends a packet and the receiver does not receive it, and it doesn't send the acknowledgement back, right? So only if the packet is sent, the acknowledgement is received. So here, if the packet is not sent, then the whole acknowledgement is not received. So after the timer, you remember, again the packet is resent to the receiver from the sender. But here the problem arises is that some bits get changed or damaged. See, we have this whole packet. Okay, consider 101111. Okay, consider this had to be 10. Consider this has become 00. Okay, the packet has been changed. Okay, packet is received but it is changed, and you know, when there is some mismatch of information, it is not complete data which you are sending is being received by the receiver. Okay, and this poses a serious problem, okay, while transmitting the messages. So what is the solution for this? We need to have some solution, right? So we have some solution also. Let us see what is that. Okay, one simple solution to detect whether some bits are changed or not is to send two packets. Okay, what they are doing is, we are sending two packets at the same time. So if at the receiver these two packets are matched, if the packets are matched, then we will get to know that yeah, it is the correct received message. If the packets have mismatch of data, then we may see which packet has been changed, and we again request back the sender to send the packet again to confirm which is the packet which has changed. But you know, sending two packets at one time, sender sending to the receiver two packets at one time, okay, you know, first of all, sending one packet only poses a lot of delays in transmission time and everything. Consider it, if it has to send two packets for everything, you know, it becomes a lot hectic, and it all creates traffic and congestion and everything. So for that, we have something which can detect the error in the message. If there is an error in the message, we can detect it by something called as cyclic redundancy check. Okay, this cyclic redundancy check is something that which only detects whether the bit has changed or not. Okay, but it does not give us a solution. Fine. So it is basically a polynomial. We use a polynomial in cyclic redundancy check. Okay, we also call it as a CRC in short form, cyclic redundancy check. Here, CRC polynomial generator. See, this polynomial generator will be known by sender and receiver both. Sender and receiver both will know the polynomial generator. Here, if you can see, the maximum value is x to the power of 3, right? But this can extend up to x to the power of 32. You getting how many values it can have? X to the power of 32. It can have so many, that x to the power of 31. Sorry, totally it is 32 bits, but it can be extended up to x to the power of 32. Here, since it will become difficult for us to, you know, understand, what I have done is I have taken only to the x to the power of 3. See, I have generated something called as CRC generator here. So how did I get this CRC generator? See, here you have taken this polynomial, right? What is the polynomial? X cube plus x square plus 1. So if you can see here, x is missing, right? The polynomial, if it is a complete polynomial, it should be like x cube plus x square plus x plus 1, right? Since x is missing here, which means this is taken to be 0. Okay, this value should be taken as 0. In this expression, in this polynomial, this value is missing, so we are going to take that value of 0. Otherwise, see, we have x cube, yes, x square, yes, 0, 1. So this is how we generate the CRC generator. Okay, did we know? From the polynomial, by using the polynomial, we generate the CRC generator. Fine. Now we have something to send. What is this? A data. Okay, here, look here, there is some data to be sent. What is the data exactly? 10 10 11 011. So what we will do is we will assume something called as, we will assume that maybe CRC is generated, and what we will do is we will append 3 zeros, to this data which we are sending. Okay, now let us see how we are going to generate the actual CRC. Okay, fine. See here, what is the data? 10 11 011. I told we are going to append 3 more zeros to this, so we have appended the 3 more zeros. So what we are going to do is we are dividing it by CRC generator. Okay, we are dividing it by CRC generator. What is the CRC generator? 1101. So now we start dividing it. Okay, we start division as a normal division, but yeah, actually here we are going to have XOR operation done. You know what is XOR operation? How is XOR operation done? See, if there are 0 0 0 1 1 0 1 1, if either it is both the zeros or both the ones, the value is equal to 0. If there is either of the value is 1 only, then it turns out to be 1. So now here we need to be very careful. So what is the value here? First 4 values is 1 0 1 1. What is our first 4 values here? 1 1 0 1. So when we divide it by when we divide it once, so what do we get? 1 1 0 1. Okay, so 1 1 0 1. See, this is 0, this is 1, this is 1, this is 0. So what we'll do, we'll leave out this completely. We'll take this one digit here down, so that this becomes 0. So 1 1 0 1, again ones. Okay, again ones. So again we are going to divide it by ones using XOR operation. We are going to do this. So 0 1 1, 0 0 0, 1 1 0, 1 1 0. So all these 3 values will be discarded and removed. Next, how many values are we going to take now? Next, we are going to take this one. We are going to take one more 1. But you can take one more 0. Great. Now again we are going to do the XOR operation. So 1 1 0 1 with 1 1 0 1. So see, this is 0 and 1, this is 1 and 0 1. These both are zeros and zeros, so we're gonna leave these both. Again we're gonna bring back 0 and 0, 0 and 0. So 1 1 0 1 again, 1 1 0 1. Okay, so here if you can see, this value is 1, this value is 0, this value is 0, this value is 0. So leave off this value. Okay, leave off this. The last 3 digits of the final remainder is taken to be your CRC generated. See, we have got 0 0 1, we have got 0 0 1. Can you see here? This is also 0 0 1. So now we can be sure that our CRC which is generated is 0 0 1. Now what we will do, for this actual data we will append 3 zeros. Okay, so 1 0 1 1 0 1 1 was our actual data. For this we are going to append the CRC generated, which is the CRC code generated. 0 0 1 is the generated CRC code. So see, this is the final data along with the CRC code which is going to be sent to the sender. So this is how we do the cyclic redundancy check, and we generate the cyclic redundancy code, and then we send the data. Okay, and it is always known that last 3 digits are appended. Now at the receiver side also it happens the same thing. Okay, at the receiver side we take the same data, and we again do the same procedure. if we get all the remainders as zeros, if we get all the, see here we are going to append 3 zeros, right? Here we already have CRC code appended. So what we will do, we will directly take off the value, and we are directly taking off the value, and we are going to divide it by our CRC generator. Okay, so what is the data? 1 0 1 1 0 1 1 1 0 1 1 0 1 1 0 1 1 1 0 1 1 0 1 1 0 0 1. Okay, this is now our CRC. This is now our data along with the attached CRC code. So our CRC generator is 1101. So with 1101, see how we can end up with all zeros. See, again we are going to do the XOR operation. So 1101. So this is 0 1 1 0. Remove this. Now bring this down. This will be 0. Again 1 1 0 1. This will be 1. This is 0 0 and 0. So we are going to remove this. Now we are going to take this 1 1 and this 0. So 1 1 0. So it is will be doing the XOR operation at 1 1 0 1. So 1 1 0 0. Now we have to bring back 0 and 1. Okay, we have to bring back this left out 0 and this 1. Okay, 0 and 1. See, now 1 1 0 1. Now we have got all zeros, which means our data has no bits or any changed data. Our data which is being sent has been properly sent. It has been properly received. If we get all the zeros at the receiver end, as a remainder, then we get to know that our data has been correctly reached without any packet changing or any changing of the packets or packet loss. Okay. Next, again I told you detecting the error. Again you have to do the same thing. You have to take the corrupt data and you have to divide it. If it doesn't end up with zeros, I hope you will be trying this. Just try this for yourself. 1 0 1 0 0 0. So if you can check here, which is the data, which is the bit that has been changed. See, this bit has been changed. This is 1 here and this becomes 0 here. So when you are dealing with corrupt data, what happens is you are definitely going to end up with something in the remainder which is not totally zeros. You will have remainder of some value which will not be, if it is totally 0, then your data has no errors. But here, since the data is correct, you may not know which value will change out and which is the which will identify that this data has been changed, this data has been altered. So you need to send another packet of data of the same data. So just check it out. For this you will absolutely get some other remainder instead of getting zeros, which will show that the data is correct. That is why we use CRC. So now we got to know that from CRC we are going to detect where the data has been changed or the data has been changed or not. But you cannot do anything for the changed data. It only detects that yes, the data has been corrupted, or no, the data has not been corrupted. So only it is helpful in detecting the error, if it is there or not. Next, we have something called as checksum. Okay, so what do we do in checksum? We divide the data into equal parts. So consider we have so much of data. Okay, 1 0 1 1 0 1 1 0 1 1 0 1 2 sorry, not 2, sorry, 1 1 0 0 0 1 0 1 1 0 1, something like this. Okay, we are exactly going to divided by, consider 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. So we are going to exactly divide the data into some equal size. See, we are dividing the data into equal parts according to the checksum size. We first define the checksum, and accordingly we divide the bits also. For 16-bit checksum, we divide it into 16 bits. See, for 16 bits checksum, we have to divide it, this whole part is taken. But here I thought of dividing into 8 bits, so this is 8 bits. So before dividing, you have to identify what will be your checksum size. Okay, then you will be able to divide it, and then we write the decimal representations of each bit. So we are going to write the decimal representation for this. We are going to write the decimal representation for this. So after writing the decimal representation for all of this, okay, after writing the decimal representation for all of this, we, whatever sum we get, consider we got the sum as 248. Okay, consider we got the sum as 248. Okay, so whatever sum we get, we take the negative of it. We take the negative of it, minus 248. We will make it as minus 248 and put it into the end of the data. Okay, finally we are going to send this value as minus 48, and this is at the sender side. At the receiver side, when it is doing the opposite of this, it has to, when it does all this, when again it divides and converts into decimal, and when it adds, it should become 0, because here we are converting it into negative and we are sending. So at the receiver end, it should become 0, and if it becomes 0, if again the values become 0, then we get to know that at the receiver side there is no data corruption. Otherwise we will get to know that there is some corrupt data or changed data in the data set which you have been sent. Okay, this is about checksum. You just have to understand the concept for this. So hope you've got the concept. We'll move on. Here we have one question. A computer network uses polynomials over network for error checking with 8 bits as an information, and uses see this polynomial you're going to use as the generator polynomial to generate the check bits in this network. The message is, see, it is nothing but your CRC problem which has been asked here. It is quite easy. It is very easy. See, these questions shouldn't be missed. Okay, now we are going to take the data. What is our polynomial? See, polynomial turns out to be 1 0 1 1, because here x square is not there, this part is missing, so we are taking that as 0. So 1 0 1 1 is our CRC generator, 1 0 1 1. So let us divide 1 0 1 1. Okay, sorry, we forgot to append 3 zeros here, right? Yeah, 1 0 1 1. So this is 0, this is 1 1 1. Okay, we are gonna again divide it, 1 0 1 1. Okay, so this is 1 0 1 0. Discard this. Now next, bring this one down, 1 1 0 1 1. Okay, see, again this whole things become 0. So next, bring 4 bits down. What are the next 4 bits? 0 1 1 0. So I'll continue here. 0 1 1 0 1 0 1 1 0 1 1 0 0 1 1 0 0 0. 1 0 1 1. So again it becomes like 1 1 1 0 1 1. Okay, again we are going to divide 1 0 1 1. So I'll write it up here. So it will be 0 1 1 1. Sorry, 0. This is discarded. The 0 is brought down. So 1 0 0. There's one more 0. Okay. So 0 1 1. So 1 1 1 0. Okay, again you're gonna do this and take this last 0 down. So 1 0 1 1. So the thing is like 0 1 is 1 0 1 1 1 is 0 1 0. So the CRC code is here 101. 101 is the CRC code which you finally get. Okay, finally the code which you get is 101. You just work it out neatly, you will get to know. I want you to work it out neatly. So the message here is this one, so we are going to append 101 at the last. So what is the final data transmitted is 01 011 011 and 101 is added as a CRC code. So 101, this is a CRC code. So final message is this one. Final message is this one which we are sending. Hope this session on data link layer has been understood. If not, please comment in the comment section below. I'll be replying for all your doubts. So this is the last video on data link layer, and the next session will start with the network layer, guys. Hope to see you soon. Bye.